Okay, so I'm Trotter. I'm hoping to make this not too long. Last time I gave this talk, it was for like a 40 or 50 minute long slot, and I'd like to keep it shorter because I like to drink beer, and I'd like to get a beer, and the longer I talk, the further away from a beer I am. So, can everybody hear me okay, or do I need to talk louder? Okay, so I'm going to talk to you all about Cloud Foundry. First of all, I'm the co-founder of a company called Mashion. I live up in Mountain View in the Bay Area. I go by Cashion on Twitter. I go by Trotter on GitHub. And now I'm going to talk nerdy to y'all about cool stuff. Starting with just a little backstory. 2 years ago, I used to be really, really big into Chef stuff. I still am pretty big into Chef. And so I used to give this talk about how, like, Chef is, like, awesome. This is the way we need to be deploying all of our applications. You guys are idiots if you're doing this stuff by hand or with Bash or with whatever else. Like, you should be using Chef or, you know, Puppet or CF Engine, whatever you want. Like, choose your tool, but automate that shit. Oh, yeah, also, I sometimes use profanity in my talks. I will attempt not to. It happens, so sorry. So, I did these Chef talks, and it was great, and I'm sorry for all of that. It is really cool. It is really good. Don't get me wrong, but it's not really where we need to be. It's, I think, a step in the progression. And for me, platform as a service is my new shiny, right? So 2 years ago, I was like, Chef, oh, it's so shiny, it's awesome, I can deploy things. And now I'm like, oh, wow, if I use a platform as a service, like Heroku, for example, right? I don't have to write recipes to deploy things. I just type git push, and boom, I'm on the internet, and life is fantastic. And I think that's where we want to be and where we need to be getting to. So, you know, you've got Heroku, and what you want, though, is something that when you outgrow Heroku, or you decide that, oh, wow, it turns out now that I'm running like, 50 instances, Heroku got really expensive and I need the bigger database now and they want to charge me out the butt for that. You want something you could actually run yourself. And that's where Cloud Foundry comes in. Sorry, by the way, I'm running on like the same view y'all are, so the next slide's a mystery to me as well. So, let's talk a little bit about why you'd want something like Heroku, right? Like, people talk a lot these days about writing your application as a set of services. So instead of doing this one monolithic web app, right, you want to go the Amazon route, where you've got your little web front end, and then the web tier talks to like this service and this other service and this other service. Like Twitter's doing this. All the big guys do this now, right? And they send off all the requests to all the back-end services, and life is great because they return these websites really quickly, and everything's well factored and everything runs great. But running all those services, it's like the fifth circle of hell, right? It started out, it was super easy. You had your one Rails app, and you had your Capistrano file, and you said like cap deploy, and boom, you were running. Life was good. But then somebody goes, oh yeah, I want to add this other service instead. And now you've got to like make sure that this other service is still running because the main web service has to talk to it. And this problem just gets compounded as you add more and more and more. Like each time you're like, okay, I got to go write a new Chef recipe to install this new service that I've made so that I can use it. And it's this blocker between you and writing your application the way I think it should be done. I think you should do it as services, but the ops overhead in doing it is a blocker to you actually like practicing good development. Instead you're like, I'll just put it in the monolithic app because then I know it's going to get deployed. Life's going to be easier. And what you really want to be doing is instead empowering your employees, right? You want them to be able to say, oh, I've got a new service, I just want to deploy it. Or in terms of the enterprise, you want them to be able to say, hey, I just wrote a nice little tool, and I want to be able to deploy this internally so other people can use it. What you see a lot in big companies, right, is there's like a stupid process that you got to follow, right? Like, let's say something dumb like a lot of companies love to have you enter in your hours. They're like, oh, you need to enter in the hours with the project tag that you've been working on because this is what we do now so we can track up high how much money we're spending. And you're like, okay, fine, whatever. I'll go into this stupid SAP system and I'll click some buttons and we'll have our hours entered. And you realize that's annoying. And you spend like 30 minutes every week on that. So you write a script to fix that for you. But because you don't have anywhere to deploy that script and you may not have a good way to share it or anything, you just run it locally for yourself. And you run it. And then one day Bob comes over, he's like, dude, I hate entering in hours. And you're like, oh yeah, I don't do that anymore. It just does it for me. And he's like, oh, I want that. And you're like, oh, well, I'll like email it to you. Do you have Ruby on your machine? No? Okay, let's see. You need to go install Ruby first, then you're gonna run this. Don't worry about it. It's gonna work. You're gonna be great. And this guy has no idea what he's doing. Whereas if instead you could take that nice little script and turn it into a simple little website, and then people just click the button and it goes for them, that's a lot better. But to do that, you need a place to deploy it. And if you're not running like a platform as a service or something internally, going to ops and telling them, hey dudes, I need to box this tiny little web app I've wrote to help people out. They're gonna be like, no, that's stupid. We're not gonna do that. But if they have like a platform type thing, it's much easier to convince them, yes, let's go with that. That sounds easy, because they don't have to think about it, right? They don't do it. So, Erlang OTP solved this problem of like managing a lot of individual applications and running them all in one spot and deploying them a long time ago. Erlang OTP has this concept of applications, and you write each app independently, and then they talk to each other via messages, which is a lot like what you would do when you write a services-based web application. But we don't have that for ourselves, for Rails apps, unless you use something like Cloud Foundry. What Cloud Foundry gives you is a nice platform, much like Heroku, to say, okay, I just want to push my application up here and run. And I want it to be able to know about the fact that there's a discovery service over here, and there's a user management service over there. It's much easier to get that going with Cloud Foundry than it is to get that going just by writing a bunch of chef recipes for yourself. So any questions so far? Am I going too fast? Am I sounding too stupid? Are we okay? All right, cool. So that's like why you might want Cloud Foundry. So let's talk about what it is and why. Let's talk about what it is and like how you might build that, so you can kind of better understand what it does by seeing how it's built, right? I think that's a fun way to go about things. Be like, okay, how was this made? Okay, that's how it works. And in doing this, we'll also kind of cover a little bit about what makes a good distributed system, because Cloud Foundry itself is a pretty well-written distributed system. It consists of a lot of smaller components that all run in tandem to coordinate the decently complicated activity of spinning up a web app on some box and attaching it to a database and to the internet. So to start, if you were to say, okay, I want to write a program that will allow me to deploy an application to the cloud, you might want something called a cloud controller, because this is going to be like your magical place in which you tell it, hey, I want a new application, and it controls the whole thing. And it goes, okay, you will have an application, sir, and it returns to you 200. Yay, created your application. Or like some other thing saying, wait a little bit, and here's your token to come get it in a minute. And so this is like your central entry place, and you might do this as a Rails app or something, right? And it needs to have a few commands. It needs to have a push and update command, so you can push a new app or update an existing app. You need to be able to tell it start, stop, or restart my app. And you need to tell it, this application that I just pushed to you, it needs to be running on this URL. So it needs to be running at like trottersawesomeapp.trotter.com. And so you can do this all through the cloud controller, right? And if, say, later on you wanted to change the URL, you would tell the cloud controller, oh, running on this other, trottersdumbapp.trotter.com. But the cloud controller in itself, if you really want to make a well-factored complete system, then you're going to need it to talk to something else, right? It should not be responsible both for being an API front end and also running those apps. You don't want to do both things, right? That's poor factoring. If you look at all the people who go like, oh, write your objects and have them do one thing and do it well, I think that applies to applications as well. Write your applications, have them do one thing and do them well, right? Unix said that a long freaking time ago. And so let's apply that here as well. So we've got our cloud controller, and now we're going to have something called a droplet execution agent, because we're really cute and things run in the cloud. So we have droplets that get executed. And we'll call it DEA for short, which just evokes a completely other set of ideas, but whatever. And what the cloud controller is going to do is talk to the DEA and say, hey, I've got an application that I'd like to be run. Do you have somewhere you can run it? And the DEA is going to say, yeah, sure, hand it to me. I'll run it over here. No big deal. And so what the DEA needs to be able to do is assign a port to an app. So it's going to take in this application, right? And it needs to be able to say, okay, you application, you're going to run on port 337, and I'm going to manage your resources. I'm going to make sure that you don't go using all the CPU on this box, because there may be like 4 other apps running on this box, and if you eat all the CPU, then they're going to die as well. So the DA needs to be responsible for putting these things in a container, and it needs to know about runtimes and frameworks. So it needs to know if I'm running a Rails app, then I need to call, Rails start, or set up Apache with Passenger or whatever else. But if I'm running a Java app, maybe that needs to be running inside Tomcat or something. Or if I'm running like a Python app, that I need to be starting Django and not Rails. So that's the DEA is responsible for that, for knowing how the various frameworks and runtimes actually work. But if you want to make a good distributed application, these two can't actually talk to each other, right? They can't talk directly, because if you go to the cloud controller and you say, hey, I've got a new application, I want you to run this thing, and it goes to talk to the DEA and the DEA is down, then it's going to have to tell you, oh, too bad, sucks, go home, like everything's blown up. But if you put a message queue in between, in theory, if you build a nice, robust message queue, it's going to be much less likely that it's down, and you can do nice round-robin-y type things to make sure you have multiple message queues and high availability and yada, yada, yada. So the cloud controller just puts a message on the queue and says, hey, if there's anyone out there who knows how to run a Rails application, would you please do that for me? You can go pick it up over here. And the DEA is listening on the queue going, hey, I know how to run Rails applications. I can run that for you, no big deal. And if later on you were to say, oh, well, the DEA was a dumb idea, there's a better way to run this, we can run a better version, the cloud controller doesn't need to know about this. All you got to do is spin up your new DEA, have it start listening on the queue, and it will do things your new fancy way, and then you can drain out your old ones and remove them. But those things alone still aren't enough to have us running, right? Right now, we were able to deploy, or we were able to push an application up to this service, and then the DEA runs it and assigns you a port, but you don't have to tell all your users, oh, go to trotter.com:8551. That's where the website is. So what you want to do is put a router in front, so you can route things based on subdomain. So when you tell the cloud controller, hey, this thing runs at trotterscoolsite.trotter.com, it knows that that actually means, okay, when a request comes in, I send it over to this particular DEA on port 8551. And so that's what the router handles. And in the Cloud Foundry case, the router used to be a Ruby app and potentially still is, but I think they are in the process of migrating that to being a Lua app that runs inside of Nginx. And the way this thing works is you send your request into the cloud controller saying, hey, push this app up, and the DEA pulls it off NATS, pulls a message off NATS and goes, okay, I'll run it. And then it puts another message up onto NATS saying, hey, I'm running this application on this port. And the router then goes, okay, I'm looking for this application. Good to know that URL maps to this port on this box. And then if you spin a new router up, it can query over NATS and say, hey, who's running this application? I'm going to be routing for it. And the DEAs can respond saying, here's the table of applications I'm running and what ports they're on. Oh, yeah, so I shortened it. That's the cloud controller. So that's this guy. Yep. Yeah, he didn't really fit otherwise. He would have been like really tiny and then impossible to read. So the router knows about host names, IP addresses, and ports. It's the thing that actually binds to port 80, and it communicates with the DEA and the cloud controller over NATS. So NATS is the central message exchange for this entire system. The individual components never actually talk directly to each other. They just publish messages onto NATS, and then other things are listening for the appropriate message type and say, oh, I can respond to this, let me respond. Now then, all this is good and well, but if something were to fall down and die, then you need to be able to restart it. And that's where the health manager comes in. What the health manager is doing is the health manager is looking at the state of the system. And it says, oh, it looks like we're supposed to be running 5 instances of this one application, but we're only running 3 instances of it. Let me tell the cloud controller to spin up 2 more because they're not running right now. And then the cloud controller will go out and say, hey, I need 2 more of these, and the DAs will pick it up. So this is useful in the case where, let's say that some dude has gone into the server closet and accidentally unracked a box. He just like unplugged it or whatever. And that box happened to be running a router and 2 of your DEA nodes. the health manager will, I think it polls on a every minute or every 5-minute basis, something like that. It'll recognize that decently quickly and send out a message saying we need to restart these. And so it'll add more apps, or if there's other cases that it'll do fancy things. I forget what all they are, but it basically makes sure that the whole service is running as it should be, so that in cases where things fell down when they shouldn't have, they get picked up. And so what I've just described is Cloud Foundry in a simple form. There's a few other like smaller components that exist in there to make things work even more smoothly. Like the DEA actually talks to a thing called Warden to containerize your applications. The cloud controller is being split out into multiple apps, one that handles like user authentication and things like that. The key facts about Cloud Foundry is that it comes from VMware. It's an open source project. So it was open sourced in April 12th of 2011, but I like to say it was really open source in April of 2012 because for the first year, it was open source and it lives on GitHub, but they would only do code drops like every month, every 2 months, right? So it was open source, but you only got updates every once in a while. But last April, they actually made it really open source, so they do all their development in public now, which is really nice. Like VMware has a team of, I forget exactly how many, but they have devoted significant resources to this project, and it is under a very permissive license so that you can just go and take it and do whatever the heck you want with it, and you don't have to pay them a thing. It does not require that you're running on VMware software. You can run it on AWS, you can run it on your own machines, it's no big deal. You go to cloudfoundry.org to get the happy developer site, and cloudfoundry.com to get the show this to your boss as to why this thing is cool site. Is it production ready? Yes, but I haven't run it in production myself, so I'm not going to say go do it now. I've definitely run it in small scale on my stuff and have not run into any significant issues, but your mileage may vary, right? You may turn the whole thing on and go, whoop, that crapped out. In addition, even though Cloud Foundry makes it very easy to deploy an application to it, so you've got this nice private cloud and you want to deploy something to it, it makes that simple. Deploying Cloud Foundry itself is a major pain. It is not easy. I've written a number of Chefcookbooks to try and make that easier, but they're kind of out of date now. They recently released a tool called Bosch for deploying large-scale systems, and that definitely will deploy Cloud Foundry if you have 40 boxes on which to deploy it, because Bosch runs each service on its own machine. That's something that I know they've been talking about changing, and I don't know if they changed that yet, but it's kind of a severe limitation. There is, thankfully, though, a thing called the microcloud. So you can go to cloudfoundry.org, sign up for the microcloud, and download a VM that will just run. And it contains the entire Cloud Foundry codebase in it, so you can experiment with just pushing apps to it and playing with it and seeing how this thing works. So that's the gist of the talk. So thanks. That's my email if you have any questions that you don't ask right now. And that's my Twitter again if you want to tweet me questions as well. So. Any questions? Yes?
How much overhead does the code base make on the physical machines on the application?
So,
thinking about heavy performance.
So like the DEA and stuff runs, it's pretty lightweight. It doesn't take up that much resources. But sending everything through the router, it adds a little bit. I've not measured it, so I don't know how much, but it definitely does add some. Because instead of being able to go, like direct to your Nginx instance and then directly to your app, you're going to go through a router, which is going to do a lookup to say, okay, where does this actually go? Then route it to another box, and then the DEA is going to go, okay, or well, I guess it'll just hit the right port, and then you'll return. So it's like, it's one extra hop. But I don't know exactly how much. Anything else? All right, cool. Thank you.